All right, so we were looking at this situation with the fruit flies. We had point P down here at 23, 150. And we had some point Q up here. And the question is, well, what's the slope down here closer? So what I can do is I can say, well, let's just move Q and have it get closer to point P. And as Q gets closer and closer to point P, what's going to happen is I'm going to get an average rate of change, but I'm going to get an average rate of change over a smaller and smaller and smaller area. So, for example, if I take the point 30, 265, and I've still got 23, 150, what I notice is that now the slope of this secant line is 265 minus 150 over 30 minus 23. I get 115 over 7. And I'm going to have to grab a calculator here. I could probably figure it out in my head, but 115 divided by 7 is 16.4. And so what I notice, flies per day, is that when I'm over here, I've got significantly more flies per day over that shorter interval versus the long interval where it had flattened out at the top. The question is, what is the rate of change when I am at point P? What's the rate of change when I'm at day 23? Well, I can't calculate a secant line because I've only got 1 point. But what I can do is I can take the limit as Q approaches P and say, you know what? If Q gets so darn close to P, really, really, really close, that secant line is going to resemble a tangent line. So what we'll do here is we're going to say that, draw another diagram. I've got point P, which is somewhere on the graph, doesn't really matter where. We can continue to call it 23, 150. And I'm going to take point Q, and I'm going to make the coordinates of point Q 23 plus some minuscule amount, comma, f of 23 plus some minuscule amount. And now this slope of this line becomes the slope of the tangent line. So we'll look at this as the limit as Q approaches P of the slope of the secant line equals the slope of the tangent. So I repeated myself a whole bunch of times there, but guys, this is a really, really important concept. And I'm going to show you exactly the calculation in the next video. I'm going to knock this one off so that I don't run out of time, and I'll be right back with the next video.